Alright, hello everyone, this is Scrooge. I'm going to go over how to solve a typical optimization problem from lesson 3.6. All the problems we're going to do can follow this plan over here. We're going to write a primary equation, write secondary equations, rewrite the primary equation with one variable, then use our first and second derivative tests. Alright, so here we go. Our job is to find the maximum product of two numbers. So let me write this down. We're going to find the maximum when we multiply two numbers together. And we have the secondary equation here. So we have a primary equation here. This is our primary equation, and this is our secondary equation. Well, if we were to max out this right now, it would be unlimited, right? If you pick two numbers and multiply them together, you could go all the way up to infinity. There is no max to this. So what we have to do is we have to use the secondary equation to put some constraints on this. So let's go ahead and do it numerically first. Let's see. If I were to pick out two numbers, x and y, and then multiply them together, let's see what I would have using this equation over here. So if I picked out x is 0, well, that would make y 20, and 0 times 20 is 0. Well, what if x was 1? If x was 1, this would be 2, so I'd subtract that over, that'd be 18. So if x is 1 and y is 18, then the product is 18, so that's higher. Well, what if x was 2? Well, that would make that 4, subtract it over, that'd be 16, that would be 32. What if x was 3? Well, that would make that 6, subtract that over, that would make that 14, multiply that, and that would be 242. So you can see we could just keep going up, and eventually we're going to reach a maximum. Well, let's do this numerically. The numerical way is to take this secondary equation, I'm going to rewrite it here, 2x plus y is 20, and I'm going to go ahead and solve this for y. So that makes y is equal to 20 minus 2x. Now if I take this equation and put it in here, now I have an equation that says 20, or x times 20 minus 2x. So now I can rewrite this maximum equation as 20x minus 2x squared. Now since I only have one variable here, I can find a maximum. And what's our plan for the maximum? Well, we're going to do what we did last lessons. We're going to take the derivative. So the derivative would be 20 minus 4x. Maybe I could do the first derivative test. 5 is a critical point there, right? 5, and the numbers go up, and the numbers go down, if I test it out using this derivative. Or if I take the second derivative, this is a negative 4, and that means it's always concave down. So the second derivative is always concave down. So that means there's a maximum right here. There is a maximum when x equals 5. If I put 5 in this equation, that makes it 10. So that's going to be the highest number. 5 and 10 would be a 50. There's my max x, y, and this is the max product. Now, you can see the pattern there, right? It's going higher, 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 up to 50 max. Well, what if I went to 6? Well, if I put 6 in there, that would be 12, subtract over, that'd be 8. 6 times 8 is 48. So you can see that that's why that's a max, because this equation goes up to this maximum and it goes down. We can do it numerically. That would take a long time to do. But if we follow this plan, we can do it analytically. Write your primary equation, which is right here. Write your secondary equation. They gave that to you. I rewrote it into that form. Rewrite the primary equation with one variable. Take this up here, put this in, and now we have this maximum equation with one variable. And you can solve it with the first derivative test, second derivative test, and then you'll find where that maximum point is. Now be careful, this is a maximum. If we were looking for a minimum, well, that's not a minimum. Minimum would occur at the endpoints if we had them. So sometimes you have to be very careful with the results of your test. Alright. Hope this helps.